Today we are going to see a new topic in light energy, that is constituent colors of white light from the sun. If you have passed the white light to the prism, after that the white light is split into 7 colors. This process is called dispersion. The splitting of white light into its 7 color is called dispersion. The band of the color is called rainbow. Okay, now we go for colors. Colors divided into two. First one is primary color and second one is secondary color. So what is primary color? Primary colors are the colors which cannot be obtained by the combination of other colors of white light is called primary colors. The example of primary colors, red, green and blue are the primary colors. So if you are seeing the screen of a video, TV or a computer, we are able to see all the colors. How is it possible? The screen of a color TV or a computer has an array of extremely tiny spots. And each tiny spot consists of 3 phosphorus dots of red, green and blue. So all the colors are seen on the screen. That is due to the proper combination of these 3 primary colors. By this process we are able to see all the colors on the screen. Next we go for secondary colors. What are secondary colors? The colors which can be obtained by mixing of any 2 primary colors are called secondary colors. Here these are the 3 examples of secondary colors. The combination of blue and green is called cyan or peacock. The combination of blue and red is magenta or purple. The combination of red and green is called yellow. Okay, these are the 3 secondary colors. Next we go for complementary colors. What is complementary color? A pair of colors which on combination gives the effect of white color are known as the complementary colors. Here some of the example of complementary colors: blue and yellow, green and magenta and red and cyan. These are the called as a complementary colors. Okay. Next we go for appearance of colors on an opaque object. When a white light is incident on an opaque object, what happens? Some of the light is reflected back by the object and some of the lights are absorbed by it. This process is called color subtraction. Okay, if any light is incident on a opaque object, some of the lights are reflected and some of the lights are absorbed. This process is called color subtraction. So the object is appeared to be the same color as that of the reflected light. So if it is reflect green light, then the object is looking like a green color. If it is reflect red light, then the object is looking like a red in color. So this is important, this phenomena, due to which an opaque object selectively reflects lights of few colors out of white colors and absorb light of other colors is known as the color subtraction. Okay. Next we go for, if an object reflect light of all the color, what is it meaning? If any object reflect all the colors, then it will not absorb any colors. Then the object is looking like a white. If an object looking like a black, what is the meaning of? It does not reflect any light and it absorb all the light which are falling on it. Then the object is appear as a black. For example, now we are taking a rose. The red rose is incident on or the red roses on the light of sunlight or a white light. It looking like a red color. Why? Because the roses absorbed all the colors and reflect only red color to the environment. So the rose reflect red light and absorb light of all the colors. So the roses appear red in color. If the roses on a red light, what happen? It will reflect all the colors and will not absorb any of the color. So it looking like a bright red in color. That means it reflect the whole light and does not absorb at all. Okay, that's why it is looking like a bright red in color. Okay, now at the same case, if the rose is seen in blue light, if blue light is incident on a red rose, What is the property of red? They absorb all the colors. So the blue light is also absorbed by the red rose, and there is no color to reflect. If there is no color is reflect, means the object is looking like a black in color. So the red rose seen in blue light, then it appear as a black. Why it is appear as a black? Because it absorb the blue color and does not reflect the light in all. That's why it is looking like a black in color. The same way, green leaves also appear green in what light? Or a sunlight, and because they reflect green color. In a blue light color, it appears black because it absorbs the blue color. Okay, that's why it is appear as a black. Okay, up to this we are conclude, and we will see in the next topic. Today we are going to see a new topic in light energy, that is constituent colors of white light from the sun.